Find the involutes and evolutes of the circular helix x equal to a cos of theta, y equal to a sin theta, z equal to a theta tangent alpha. Solution: here r is equal to a cos of theta, a sin of theta, and a theta tangent alpha. Now t equals to r dash equals to a minus sin theta cos of theta tangent alpha d theta upon ds, equation 1. Taking modulus of both sides, we get 1 equal to square root of a square secant square alpha d theta upon ds, or ds over d theta equals to a secant alpha. Integrating equation 2, we get s equals to integral a to theta a secant alpha d theta a secant alpha as it is, and integration of d theta is theta, so equals to a theta secant alpha. Now we know that involutes of a space curve r equals to r s and r given by r1 equals to r plus c minus s into t, that is r1 equals to, putting the value of r, a cos of theta, a sin of theta, a theta tangent alpha plus c minus a theta secant alpha into minus a sin of theta, a cos of theta, a tangent alpha d theta upon ds. If r1 equals to x, y, z, then equation of involutes are given by x equal to a cos of theta minus cos of alpha sin theta into c minus a theta secant alpha, y equals to a sin of theta plus cos of alpha cos of theta into c minus a theta secant alpha, and z equals to a theta tangent alpha plus sin of alpha into c minus a secant alpha, equation 3. Again, equation of evolutes of a space curve r equal to rs are given by r1 equals to r plus rho and plus minus rho tangent psi plus c into b, equation 4, where psi equals to integral of tau ds, equation 5. Using 2 and 1 gives t equals to cos of alpha into minus sin of theta cos of theta tangent alpha, so tau dash t dash equals to kappa into n equals to cos square alpha upon a into minus cos of theta minus sin theta 0, using 2, which gives kappa equals to cos square alpha upon a, that is rho equals to a secant square alpha, and n equals to minus cos of theta minus sin of theta 0, so b equals to t cross n equals to cos of alpha sin of theta into tangent alpha minus cos of theta into tangent alpha, and 1, so b dash equals to minus tau n equals to cos square alpha upon a tangent alpha into cos of theta sin of theta and 0. Which gives tau equals to sin of alpha cos of alpha upon a, so psi equals to 1 integral of 1 upon a sin of alpha cos of alpha ds, 1 upon a as it is, sin alpha cos alpha as it is, integration of ds with respect to ds is s, so equals to theta sine alpha, because s equal to a theta secant alpha. Also let r1 equals to x y z be the position vector of a current point on the evolute. Putting these in equation 4, the equation of evolutes given by x equals to a cos of theta minus cos of theta secant square alpha minus a secant square alpha tangent c plus theta sine alpha into sine of theta sine of alpha, or x equals to a cos of theta into 1 minus secant square alpha minus a tangent alpha secant alpha sine theta tangent c plus theta sine alpha, or x equals to minus a cos of theta into tangent square alpha minus a into tangent alpha secant alpha sine theta into tangent c plus theta sine alpha, and y equals to minus a sine theta into tangent square alpha plus a tangent alpha secant alpha cos of theta into tangent c plus theta sine alpha, equation 6. So equation 5 and 6 gives required equation of involutes and evolutes respectively.